Good morning, everybody. This is Mr. Spegler. We're going to do a lab today, and I just need to get you to a point where you're ready for the lab. So, a quick review of yesterday. Yesterday, we talked about humidity, and it's just a measure of the amount of moisture that's found in the air. If you remember, the air is made up of mainly nitrogen, quite a bit of oxygen, and then some minor gases. But when we did this, we didn't concern ourselves with water vapor because the amount of water vapor varies quite a bit uh, from location to location as well as from time to time. So um, there's three kinds of humidity. There's absolute humidity, where we measure the weight of water in a certain volume of air. There's relative humidity, where we take a look at the amount of water in the air compared to how much it could hold at a given temperature. And then dew point is the temperature at which you get down to where the amount of moisture in your air becomes saturated, where you could hold no more. So when the air gets cold enough that it has to start shedding moisture out of it because there's just too much in there. So those are the three types that we expect you to know and understand. Um, so here's that absolute humidity. That's what Amplify uses. So you have a certain volume and you have a certain weight of vapor in the air. So that's just kind of an absolute amount. Okay, we don't generally use that. Uh, Here's relative humidity, what this lab is all about. So we're comparing the amount of water vapor to how much the air can hold. So here is 100% relative humidity. So this water vapor, the amount that's in the air, is as much as it can hold. If it gets any colder than this, the water will have to come out. So that's 100% relative humidity, also called the dew point. When the temperature warms, let's say this morning as the temperature gets warmer, chances are that's the same amount of water vapor in the air. But what's happening is the air is getting warmer, which means it can hold more moisture. So the relative humidity actually drops as the day starts. And as it continues to get warmer, that's if the water vapor amount stays the same, the relative humidity drops because you've got the same amount of water, but you've got a capacity to hold a lot more water in the air. Okay, but that's only if evaporation and things like that aren't happening. All right. So how do we do it? Well, we need two thermometers. We have a wet thermometer and we have a dry thermometer. And as you know, as you get out of a shower, get out of a pool, you're cold because the evaporative cooling that happens when you sweat, when you're wet, it carries the heat away from you. It pulls the heat away from you. So if you've got a wet thermometer and you swing it around, it'll get cold. And it'll get cold down to the temperature that's actually the dew point. And so what we do is we compare that dew point to the actual temperature. Okay, so we're going to use a chart like this, and we'll get to that in just a moment. So the dew point, I'm not sure. We were really close to it today. I didn't look to see, but in the summer, this very often happens where the temperature drops below the saturation point, the dew point, where the most water vapor that can be held in the air is held in the air, so the air has to get rid of it, and it'll release some dew on the grass, or in this case on a web. That's the dew point. And during the dew point, if it happens just above the ground level, we have fog. If it happens up elevation, we have clouds. It doesn't necessarily mean that we're going to have rain, but you'll have some sort of water droplets forming, very often small. So remember that as you get dew point, as you get higher and higher, it gets more and more miserable to be out there. All right, so that's it for a quick review of yesterday. Now I'm going to pull up today's activity. So in Teams, you'll find today's activity. It's called Lab Relative Humidity. And you'll go here. We're going to watch an explanation video, what you're doing right now. Fill out the tables in the Excel worksheet. That's this right here. And then in the worksheet, there's a link with some questions. You have to make sure to do those questions, otherwise you're not going to get credit for the activity. So whenever you're doing these, go here and open in Excel or open in Teams. Either of those makes it easier for me to see. It's not so difficult. A lot of you are still having difficulty with that. And it'll come up and it'll look like this. All right. So first put your name in here. So it says read only. I'll have to click on edit and put my name there. And basically anything that's yellow you need to fill out. Okay, so yesterday I set up a couple thermometers. So here's a lab thermometer, and here's one that's basically got some paper towel on it that's wet, and I had a rubber band to hold it on. Okay, so this is the dry bulb, your standard thermometer, and here's the wet bulb. And that one's cooler, just like when you get out of a shower, you're chilly, or a pool, you're chilly. Um, that cools down this thermometer. So we have a dry and a wet bulb. Okay, so that's what I set up, and then I waved it around for a while in my place, and I came away with a couple different temperatures here. So if you notice on the, now let's take a look. The dry bulb's on the left. So the dry bulb temperature was 21 to 23 degrees Celsius. So I'm going to put 23 here. And then the wet bulb temperature, it looks like it's 19. So I'll put 19. All right. And what's the difference between 23 and 19? Hopefully you said 4. So then it says relative humidity. Well, how do I get that? Well, I need to remember this dry bulb temperature and this temperature difference. So 23 and 4. I scroll down to here. Dry bulb temperature 23, so it's between 22 and 24, and 4. So I go over to here. And so it's 4. And so it says 68, 69. So it's somewhere between 68 and 69%. So I'm going to say 68%. All right, so don't get too worked up about it if you're between numbers. All right, so I'll leave you to do the other one. The other one is right here. I did the same thing, but I went outside and did it, and you'll see that the numbers are different. So you'll follow my lead when you do that. Okay. Then what I did is I looked up data from St. Cloud yesterday at the airport. Now, airports are a place where they have weather stations, and that's because airplanes use barometric pressure, which we'll learn about later this week, to figure out how high they are as they climb higher in the atmosphere. There's less pressure, but the pressure varies from day to day. So somewhere along the line, someone thought, hey, it's a great idea to have weather stations at airports. So this is a St. Cloud weather from the St. Cloud airport. And so I came away with this data. At 1 in the morning, the day before yesterday, it was 9 degrees Celsius out. And the wet bulb temperature was 4 degrees. Okay, so 9 minus 4 is, that's right, 5. And the relative humidity then, we have to remember 9 and we have to remember 5. So I scroll down here and I get 9 is between 8 and 10, and 5 rows over, it's about 51. So I would put 51 down here. Okay. All right, so maybe you don't want to use that chart. Another thing you can do instead of doing that is remember your dry bulb temperature and your wet bulb temperature. Just happens to be the same, so we know it's going to be 51. So I'll just tap that in there, and you're going to know this one as well. But I'll do the 11 and 4. So that's a big change. So 11 and 4. So what we can do instead is we can go to, shoot, I had a link here. Oh, no, that's not it. Oh, darn. If you just do a search, relative humidity calculator, and it'll give you a site where you can punch this in. So you can just check, you can check this or just do the same search I just did. And if you remember, the temperatures, dry bulb, dew point is the wet bulb. So I believe, well, we did 9 and 4, and then what was the other one? Let me look. Shoot. It was 11 and 4. So the temperature was 11 degrees, and it was Celsius. Have to make sure Celsius is tabbed. And the dew point was 4, that's the wet bulb. And then I do calculate, and it just tells me 62%. So I'll fill that up, 62%. So either way, it's fine. So you're going to complete these tables. Once you do that, go to questions, and you'll see, as you've seen before, there's a series of questions that have you answer regarding this. And let me go through them. The measure of the amount of moisture contained in the air is humidity. The measure that compares the amount of moisture to the greatest amount it could hold is relative humidity. The temperature at which air holds as much water as it can is dew point. If the dry and wet bulb temperatures are the same, let's take a look. If they're the same, so they have zero difference, it's 100%. So it's 100%. If the dry and wet bulb temperatures are the same, it's the dew point. These questions you're going to have to answer based on your results. And do your best answering this one. This one's important. It's going to be worth quite a few points, so do a good job. Make sure to rephrase the question in your answer and do your best. If you're not right, that's all right, but I want a meaningful answer and some data backing up your claim. So that's it. Good luck and have some fun.